All right, it's 10:30. I guess we'll get started. Y'all enjoy your weekend? I wish it was longer. The plan for your third exam is it's going to cover 8 and 9, but there is one section in 9 that I will drop. That way we can finish it. And it is section, let me see which one it is. I think it's 9.3. I'm not for sure. Yeah, section 9.3 will drop. It's one of the ones you can drop, and I'm going to do it so that way we can finish all the stuff we need to cover. Sound like a plan? All right, now let's pick up where we left off last time. It's on page 8.6, or not on page 8.6, on section 8.6, on page 23. So we went through example 2, didn't we? On page 22. Okay, then let's start on 8.6. So just like we did in chapter 7, you can create confidence intervals. So that's what we're going to do in this section. So when we do two-tailed hypothesis test, we can use confidence intervals to make a decision about the hypotheses, and it will give you the same decision as if you use either of the critical or traditional critical or p-value methods. And here is the decision rule. It's pretty simple. If the interval contains the hypothesized value, then fail to reject null hypothesis. And then if we fail to reject whenever it actually contains the hypothesized value, then obviously the opposite of that is the next one. If the interval does not contain the hypothesized value. Then what? Then reject null hypothesis. Simple as that. So we're going to go back to using the formulas for chapter 7 to calculate confidence intervals and use them in this chapter to do hypothesis testing. And I don't know if I put this on there or not, but it says, I did this on here, that way you know. Note, what is the first one? Make sure you compute the correct confidence interval. That meaning, number one, are we doing a confidence interval for the population mean mu or the population proportion p? Number two, is it a z or t interval? So we do a z interval for the population mean if we know the population standard deviation, and we do a t interval if we don't know the population standard deviation. And then for a proportion, the confidence interval will always be a z interval. or at least in here it will be. And then number 3, the final thing, confidence level. And remember that is equal to 100 times 1 minus alpha %. And why do I mention that? Because it'll say in the problem at that level of alpha. So it's going to tell you alpha. And from that, you can figure out what the confidence level that you want is. Everyone okay up to there? Then it mentions 3 pretty common used values of alpha. If alpha is 0.01, then what is the confidence level? What do you think? If we plug in 0.01 here, what do you get? Yeah, 99%. So I guess number 1, alpha is 0.01, corresponds to a 99% confidence interval. What about the second one, 0.05? 95. And what about the last one, 0.1? 90, yeah. Everyone get why that is? Just plugging alpha in here. We all get up there? Great. Then it says, note, one-tailed tests can be done using confidence intervals as well, but we won't talk about them in this class because they don't theoretically have lower limits. So if you want to do a confidence interval for the upper tail, so a right-tailed test, then the lower limit could be either be negative infinity or 0, depending on what the situation is. So we're not going to talk about those. So only use the confidence interval method whenever you're dealing with a 2-tailed test, not a 1-tailed. Then look at this first example. It just goes back to one of the examples we did already, but instead of using p-value method or whatever we used, it uses a confidence interval. And you will still get the same decision. All right, example 1. A medical investigation claims that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim at alpha is 0.05? The first part is the same as it always been this whole entire chapter. State the null and the alternative. Part 1. The null being what? Yeah, correct. Mu equals 16.3. And the alternative? Close. Yeah, not equal to it. Then part 2 is to state your decision rule. So this one's a little bit different. Then just using this, reject the null hypothesis. If 16.3 does not fall in the 95% confidence interval for what population parameter? You. Then the next part says compare the confidence interval to the hypothesized value. First, you need to know what kind of interval you're doing. So what is it, a Z or a T? Do you know S or sigma? You know S. So the sample standard deviation, that's S. So since we know S, then we use a T interval. And then to find the critical values, what you need to know. You need to know two different pieces. The level of alpha and what else? Yeah, you need to know the sample size. So you need to know the degrees of freedom. So the degrees of freedom is equal to the sample size minus 1. The sample size is 10. So degrees of freedom is equal to 10 minus 1 or 9. So then the critical T alpha over 2 can be found by looking at a two-tailed alpha of 0.05 and intersect that with 9 degrees of freedom. And someone tell me what you get. Anyone find it? I got 2.262. Is that right? Then you just use the confidence interval formula that you have. The point estimate X bar plus or minus the margin of error, which is the critical value times the standard error. And just plugging those in, what was the sample mean? Yeah, 17.7. Plus or minus 2.262 times S, which was 1.8, over the square root of N, which is square root of 10. Someone tell me the lower and the upper limit for that. To 2 decimal places. Yeah, correct. 16.41 to 18.99. So that's the confidence interval. And what it says is compare the confidence interval to the hypothesized value. So it's basically saying, does the hypothesized mean fall within that confidence interval? No, 16.3 is not in that interval. So no, 16.3 is not in the 95% confidence interval for mu. Then based on that, you come to the decision in part 4, which is what? So if the parameter was not in the hypothesized value was not in the confidence interval for the parameter, then you reject the null hypothesis. Thus, we can reject the claim that the average number of infections is 16.3. Everyone okay with that interpretation? That is something like it let us ask on your homework. Then I would recommend knowing how to do this last part. What type of error could have been made and why? So type 1 error occurs when we reject a null hypothesis when it's actually true. And type 2 is when we fail to reject a null hypothesis when it's actually false. In this case, what did we do? Reject or fail to reject? Reject. So therefore, the only type of error that could have been made was type 1. Type 1 error because we rejected HO. Does that make sense? Okay. You can expect to see a question like that on the exam. Does everyone understand how we did that first one? Now y'all do the second one. In this case, it's not a confidence interval for mu, it's a confidence interval for what? P, yeah, for the proportion. So the confidence interval formula will be different. Do y'all remember what it is? All right. P hat plus or minus Z alpha over 2 times the square root P, is it P hat in that case? Yeah, P hat times 1 minus P hat over N. So all I need to identify is P hat, N, and the critical value. The critical value is something we use all the time. It's the same one. Does anyone have part one? What is the null? Yeah, P equals 0.17. What is the alternative? Yeah, P does not equal 0.17. So that means that part one is this. Oops. What's up? Sorry, I turned the volume off earlier because I was talking to a student. Now can you hear me? Okay, sorry. I forgot to turn my volume back on. Then, since 0.17 is inside that interval, what is your decision on part 4? Yeah. So fail to reject. The null hypothesis. Thus, we cannot reject the claim that 17% of 2 to 19-year-olds are obese. Sorry, I'm sitting down. I don't feel too good. Is everyone okay with that interpretation? How many of y'all have actually finished most of the chapter 8 homework? How many of you hate part 5 on every question? That's the confusing part. Don't worry, there's more of it in chapter 9. But I was nice and took 2 of the homework problems off. And why did I do that? Because it's the stuff we won't be covering. Everyone okay with that? Okay, cool. The last question, what type of error could have been made and why? Yeah, type 2 because you failed to reject. That's the final question. Are there any questions over any of that? Okay, great. That is all for chapter 8. Let me pause the recording. That way I can just have a separate one for chapters 8 and 9.